Now see, today we have to start one more topic, that is third, kinetic theory of gases. Kinetic theory of gases and radiation. Today we have to see one more topic about kinetic theory of gases and radiation. In this topic we have to see first ideal gas equation. Ideal gas equation. Ideal gas equation can be obtained by Charles law, Charles, Charles law, Gay-Lussac law, and Boyle's law. Charles law, Gay-Lussac law, and Boyle's law. Charles law. Volume of given mass of gas is directly proportional to its absolute temperature at constant pressure. म्हणजेच प्रेशर कॉन्स्टंट असेल तर व्हॉल्यूम इज डायरेक्टली प्रोपोर्शनल टू ॲब्सोल्यूट टेम्परेचर. Gay-Lussac law, pressure is directly proportional to absolute temperature at constant volume. Means volume as well as pressure is directly proportional to absolute temperature. And Boyle's law, at constant temperature, pressure of given mass of gas is inversely proportional to volume, which implies PV is equal to constant. तीन लॉ आहेत. तीन लॉ कोणते? चार्ल्स लॉ, Gay-Lussac law, and Boyle's law. Charles law, volume is directly proportional to absolute temperature at constant pressure. Gay-Lussac law, pressure is directly proportional to absolute temperature at constant volume. And Boyle's law, at constant temperature, pressure is inversely proportional to volume. That is PV is equal to constant. आता या दोन लॉ मध्ये volume as well as pressure are directly proportional to temperature, and therefore we can write PV is directly proportional to absolute temperature. To remove this proportional sign, we have to take constant, that is PV is equal to nRT. Suppose this is equation number 1, where N, that is number of moles of gas, and R, that is universal gas constant. Universal gas constant. आणि याची व्हॅल्यू असते 8.314 जूल per mole Kelvin, like this. N, that is number of moles. R, universal gas constant. This is called as ideal gas equation. What is ideal gas equation? That is PV is equal to nRT. N, that is number of moles. आता समजा आपल्याला नंबर ऑफ मोल्स काढायचा असेल तर त्याचा पण फॉर्म्युला असा आहे, मास ऑफ गॅस डिवाइडेड बाय मोलर मास. molar mass. Mass of gas divided by molar mass, that is m divided by m naught. M mass of gas, molar mass m naught, which can also be written as number of gas molecules. Number of gas molecules in gas to the number of molecules in 1 mole. Molar mass means number of molecules in 1 mole of gas. एका मोल मध्ये किती मॉलिक्युल्स आहेत त्याला म्हणतात मोलर मास. ओके, दिस इज अबाउट आयडियल गॅस इक्वेशन. In this case, universal gas constant R can be written as Na into Kb. Kb किंवा फार तर N naught म्हणूया, N naught into Kb, where Kb is called as Boltzmann constant. Boltzmann constant. Universal constant R is equal to N naught into Kb. आता याच फॉर्म्युल्यावरून समजा आपल्याला N naught ची व्हॅल्यू बनवायची असेल तर N naught ची व्हॅल्यू काय होईल? N naught या फॉर्म्युल्यावरून N naught हिता आला तर N खाली घ्या, म्हणजे हिता आला N divided by small n into Kb, आणि ही व्हॅल्यू समजा आपण हिथं ठेवली, हीच व्हॅल्यू हिथं ठेवली तर हेच इक्वेशन तयार होईल. PV इज इक्वल टू n ला n कॅन्सल, n इंटू Kb इंटू T, n इंटू Kb इंटू T. This is also called as ideal gas equation. खर तर स्टँडर्ड आयडियल गॅस इक्वेशन हेच आहे, पण हे लिहिलं तरी चालेल. व्हॉट इज आयडियल गॅस इक्वेशन? दॅट इज PV इज इक्वल टू nRT. N number of moles of gas, R universal gas constant, and number of moles, that is total mass of gas divided by molar mass. Molar mass means number of molecules in 1 mole. Molar mass means number of molecules in 1 mole of gas. Okay. It is also called as Avogadro's number असं म्हटलं तरी चालतं त्या ठिकाणी. This is about ideal gas equation. Now, one more term about mean free path. Mean free path. One more term, that is mean free path. We know that gas consists of extremely large number of small molecules, and all gas molecules are always in the state of random motion. Gas consists of extremely large number of small molecules, and all these molecules are always in the state of random motion. Means these molecules move with different directions with different velocities. The distance covered by molecule between two successive collisions, the straight line path covered by molecule between two successive collisions. Straight line path covered by molecule between two successive collisions with uniform velocity. with uniform velocity is called as free path. पहिला आपण काय पाहतोय अबाउट फ्री पाथ. The straight line path covered by molecule between two successive collision with uniform velocity is called as free path. मग हा झाला फ्री पाथ, हा झाला फ्री पाथ, हा झाला फ्री पाथ, हा झाला फ्री पाथ. या सर्वांची ऍव्हरेज त्याला म्हणतात मीन फ्री पाथ. व्हॉट इज मीन फ्री पाथ? The average of all free paths. The average of all free paths means average of straight line paths covered by molecule between two successive collision with uniform velocity is called as mean free path. That is lambda is equal to, फॉर्म्युला असा आहे 1 divided by √2 into pi d square into rho, where d that is diameter of gas molecule, rho density of gas. d diameter किंवा ऍव्हरेज डायमीटर किंवा मीन डायमीटर पाहतो ना, मीन डायमीटर ऑफ गॅस मॉलिक्यूल, रो दॅट इज डेन्सिटी ऑफ गॅस. दिस इज अबाउट मीन फ्री पाथ. डेफिनेशन. व्हाट इज फ्री पाथ? द स्ट्रेट लाइन पाथ covered by molecule between two successive collision with uniform velocity is called as free path, and average of all these free paths is called as mean free path. त्याची व्हॅल्यू असते लॅम्बडा इज इक्वल टू 1 डिवाइड बाय √2 पाय डी स्क्वेअर इंटू रो, वेअर डी डायमीटर ऑफ गॅस मॉलिक्यूल, रो डेन्सिटी. ओके. याच्या थोडं पुढे जाऊन आपण एक महत्वाची टर्म पाहतोय, ती म्हणजेच अबाउट प्रेशर एक्झर्टेड बाय गॅस. प्रेशर एक्झर्टेड बाय गॅस महत्वाचं एक्सप्रेशन आहे. 4 मार्काला वगैरे विचारलं जातं, 3 मार्काला वगैरे विचारलं जातं. पहा, प्रेशर एक्झर्टेड बाय गॅस. Suppose this one as coordinate system. Suppose this one as a coordinate system like this. इथं आपण एखादा क्युबिकल कंटेनर घेतोय. समजा या ठिकाणी हा एखादा क्युबिकल कंटेनर आहे. X, Y, Z axis. C. Consider a cubical container having perfectly elastic walls. Consider a cubical container having perfectly elastic walls perfectly elastic walls with sides parallel to coordinate system. आपण या ठिकाणी क्यूबिकल कंटेनर कन्सिडर करतोय. कन्सिडर अ क्यूबिकल कंटेनर having perfectly elastic walls. Walls कशा आहेत? Parallel to coordinate system. Let L length of each side of cube and therefore A, that is L square, area of each face of cube, and phi, that is L cube, volume of cube. N, that is number of gas molecules. Number of gas molecules. Small m, mass of each gas molecule, and therefore density of gas, density, that is total mass divided by total volume. यामध्ये जो आपण आयडियल गॅस कन्सिडर करतोय त्याचं टोटल मास डिवायडेड बाय व्हॉल्यूम, दॅट इज डेन्सिटी. मास, एका मॉलिक्यूलचं मास स्मॉल एम, असे एन मॉलिक्यूल्स आहेत. मग टोटल मास ऑफ गॅस एम इंटू एन डिवायडेड बाय फी. सपोज दिस इज आवर इक्वेशन नंबर 1. आतापर्यंत आपण काय केलं तर डेन्सिटी तयार केली, डेन्सिटी ऑफ गॅस. नाव consider one gas molecule moving with velocity, suppose v1. Consider one gas molecule moves with velocity v1. Let v1x, v1y, v1z are component of velocity v1. याचे कॉम्पोनंट म्हणजे या व्हेलॉसिटीचा एक्स ऍक्सिसचा कॉम्पोनंट, वाय ऍक्सिसचा कॉम्पोनंट, झेड ऍक्सिसचा कॉम्पोनंट. v1x, v1y, v1z are component of velocity along x, y, z axis respectively. Then v1 square is equal to v1x square plus v1y square plus v1z square. Suppose this is our equation number 2. v1 square is equal to v1x square plus v1y square plus v1z square. Therefore, initial momentum, तो फार तर पहिला मॉलिक्यूल आपण नाव. Suppose that this molecule moves with velocity v1x along x-axis, then initial momentum of molecule before collision, that is what is by momentum, mass into velocity मॉलिक्यूलचं मास स्मॉल m, त्याची व्हेलॉसिटी v1x, that is mass into v1x. Initial momentum of that molecule, that is v1x. Final momentum, of molecule आफ्टर कोलिजन. समजा हा मॉलिक्यूल या डायरेक्शनला जातो, कोलाड होईपर्यंत बिफोर कोलिजन मास इंटू व्हेलॉसिटी, व्हेलॉसिटी या डायरेक्शनला. कोलाड झाल्यानंतर तोच मॉलिक्यूल त्याच व्हेलॉसिटीनं पण अपोजिट डायरेक्शनला जाईल. व्हेलॉसिटी रिमेन्स कॉन्स्टंट. कोलाड होईपर्यंत हा मॉलिक्यूल या डायरेक्शनला, कोलाड झाल्यानंतर त्याच व्हेलॉसिटीनं अपोजिट डायरेक्शनला, and therefore final momentum becomes minus mv1x, and therefore change in momentum of molecule. मॉलिक्यूलचा मोमेंटम किती चेंज होईल? फायनल मोमेंटम मायनस इनिशियल मोमेंटम मायनस 2mv1x. फायनल मोमेंटम मायनस mv1x. इनिशियल मोमेंटम हिथं, फायनल मोमेंटम हिथं. चेंज इन मोमेंटम त्या दोघातला डिफरन्स घेतला. मॉलिक्यूलचा मोमेंटम एवढा चेंज होतो. Change in momentum of molecule minus 2mv. Negative sign shows that molecule has lost momentum. मग जेवढा मॉलिक्यूल लॉस्ट करेल तेवढा ऑल गेन करेल. Therefore change in momentum of all plus 2mv1x. This is change in momentum. Therefore change in momentum, that is del px, is equal to 2m into v1x. Now distance covered by molecule between two successive collision on same wall. समजा हा मॉलिक्यूल सुरुवातीला हिथं कोलाड होईल. हा मॉलिक्यूल सुरुवातीला हिथं चेंज इन मोमेंटम, दॅट इज डेल px. चेंज इन मोमेंटम हे नको यार, चेंज इन मोमेंटम m2mv1x. Now distance covered by molecule between two successive collision on same wall, that is 2l. Okay. Therefore period of collision on same wall, that is period t is equal to distance covered between two successive collision on same wall, that is 2l, divided by velocity of that molecule, that is v1x. Distance covered 2l divided by त्याची velocity v1x, and therefore force exerted on wall, force exerted, exerted on wall, f1x is equal to, what is force? That is change in momentum, rate of change of momentum, rate of change of momentum, which is equal to change of momentum divided by time, that is 2m v1x divided by time आहे 2l divided by v1x, 2 ला 2 cancel, which is equal to m divided by l into v1x square. This is force exerted by molecule on wall, first molecule. Force exerted by first molecule, and therefore total force due to all molecules, that is Fx is equal to m by l constant आहे. पहिल्याची व्हेलॉसिटी v1x स्क्वेअर प्लस दुसऱ्यासाठी v2x स्क्वेअर प्लस लासाठी vnx स्क्वेअर. हा झाला टोटल फोर्स, and therefore pressure along x-axis px is equal to what is pressure? Force per unit area, म्हणजे इथं एरिया डिवाइड केलं l into l square म्हणजे l cube, m divided by v into bracket v1x square plus v2x square plus vnx square. This is pressure along x-axis. Similarly, pressure along y-axis, pressure along z-axis, बरोबर आहे. जेवढा प्रेशर x ऍक्सिसला तेवढाच y ऍक्सिसला तेवढाच z ऍक्सिसला. Also, but pressure along x-axis is equal to pressure along y-axis is equal to pressure along z-axis. Suppose this pressure is Pc, and therefore average pressure that is P is equal to average pressure, फार तर P नॉट घेतो, average pressure that is Px plus Py plus Pz divided by 3. तिघांची सम करून 3 डिवाइड केलं, that is इथं P0 plus P0 plus P0 divided by 3, that is 1 by 3 into P0. P0, that is value of Px, which is equal to 1 by 3 m divided by v into n v bar square. This is nothing but mean square velocity. Since mean square velocity is equal to v1 square plus v2 square plus dash vn square divided by n, and therefore average pressure P is equal to काय फॉर्म तयार होईल मग 1 by 3 m n v bar square divided by v. This is volume, this is velocity, that is 1 by 3 rho v bar square. This is an expression for average pressure exerted by gas. Okay.